Good afternoon, everybody. I am audible clearly? Fine, fine. I have turned my web camera on. I hope I am visible. Bhagesh, your problem is solved now. You don't have any difficulty to attend any of the sessions. Am I right? Good. Very less attendance. Shravan, you are attending first day. This is your first day for the session. You started on Monday. This is your first day for the lectures. Okay. So keep regular attendance henceforth. Don't remain absent for any of the sessions. Even though you could watch the videos later, but it is better that when you are attending it live, so you can give the proper attention. Now we'll quickly recap the things that we learned in the last lecture. And as far as the discussion for today's lecture is concerned, we'll be giving some insight for the energy consumption patterns, then the installed capacities and the proposed or the future plans at the state level as far as Maharashtra is concerned. So that will complete the first part of unit number 1, the energy scenario, the consumption installed capacities for the different conventional as well as the non-conventional plants at global level, national level and the state level. And if the time permits, we will definitely move on to the second part of unit number 1, which essentially deals with the economics of the power generation, the different costs which are likely to be incurred in the generation of an electricity. So we'll have a quite detailed discussion on what different costs should be taken into consideration while making the energy calculations for the cost of generation for that matter. So that is what typically the points which are supposed to be highlighted, supposed to be discussed in next 1 hour. So I will share my screen and we can start with the discussion for today's lecture. We'll quickly recap the things that we had in the last session. We will discuss regarding the status of the power generation in India. That is, how much is the installed capacity from the different power plants in India, from the conventional as well as the non-conventional, and how much number of units are normally produced with the latest data that is available by the end of July 2020. So these were some of the facts or the numbers that we discussed in the last session. Per capita consumption, that is nearly 917 kilowatt hours. Then the trends in the generation of an electricity that we have seen for the a typical period of or interval of 5 years, every 5 years, and it was observed that the things post 2024 to 2042, so those are going to change, where you can have the very less share for the fossil fuel based electricity as compared to the renewable based electricity generation, isn't it? So nearly 50% of the energy, it will be seen there on the right hand side. So nearly 50% of the energy will be coming from this renewable based energy. This one. Okay. So that is a good sign. Then that is nothing but the pie chart for the various contributions or the share from the various sources which are used for the generation of an electricity and their installed capacities. Number of units which are generated over the last 10 years. So those are say highlighted, and the data which is taken from the Government of India website only, Power Ministry. This is only applicable for the conventional sources. It's a fossil fuel based oil, gas, and the coal, you can say. Okay, units which are generated are expressed in terawatt hours, and annual generation is mentioned there along the x-axis. Okay, after interval of every 1 year, one calendar year. We also discuss these facts toward the end of the last lecture, and it is expected that the total demand for electricity in India, so that is expected to cross 9,50,000 megawatt by the end of 2030. Okay, by March 2020, the ambitious target has been set to have the installed capacity nearly equal to 4,60,000 megawatt, isn't it? So within a short span of the 10 year, the capacity should be doubled from 4,60,000 megawatt to 9,50,000 megawatt. So these numbers also, so we have discussed in the last session. That is nothing but 20 megawatt target has been set up by 2020, which can be obtained from the solar power plants under the National Solar Mission. And we have discussed one power plant of 750 megawatt that was installed, or inaugurated recently, or maybe say a month year back, by our Prime Minister. And the leakage losses is one of the say, major reasons. So losses are resulting around 28%, so which results in the frequent power cuts, load shedding, and the problems which are specifically faced in the rural areas. That also we discussed toward the end of the lecture. And some numbers which were say given, so to have the comparison for some recent past, that is 2012, and the numbers which are say available currently, that is by the end of July 2020. Okay, power generation capacities from the state, central, and the private sector. So we have seen that the lion's share or the major share is taken there by the private sector. Installed capacity largest there in the private sector, 47%, 1,74,000 megawatt nearly. Then installed capacities from the different sources of the power: hydro, thermal, nuclear, and the renewable energy sources. So definitely the growing demand is there for the renewable energy sources. The last one. So currently it is around 87,700 megawatt, accounting around 23.6%, or say nearly 1/4 of the total requirements. This is one table that you can go afterwards, details into the numbers which are given there at the different what you can say the regions in India: north, western, southern, eastern, southeastern, and a combination of all the power plant, thermal, nuclear, hydro, and the renewable energy sources. The suggested targets and to what extent this would have been achieved, and their deviation in absolute numbers, and the deviation in the percentage that is shown here, whether the target is achieved or not. If it is negative, if the number is often negative, it means that the target is not been achieved to that extent, and the corresponding deviation in percentage that is given. Now coming on to the discussion at the state level, so we'll have some discussion for the energy scenario at the state level. Maharashtra being the second most populous nation in the country, and it produces around 14% of the total installed capacity is there in the Maharashtra only. and it is considered to be one of the largest, what you can say, the most industrially developed. So definitely to satisfy this industrial demands and the second most population being, so definitely the capacity would have been on the higher side. So still it is around the 14% of the total installed capacity at the national level. Now these are the installed capacities for the different types of the power plants across Maharashtra. Some of them have been highlighted here. Some old facts are being taken. Some recent facts, recent numbers would be also coming in the uh, next slide, so that we can have the appropriate comparison, that by what extent, by what amount, by what percentage the capacity have improved or the capacity is added at the state level. So the different types of the power stations are given, then how many number of units are used, and the size of each unit, and the total installed capacity for the power plant. So initially it is mentioned about the thermal power stations, then gas turbine power stations, and hydropower stations. Thermal power station, Koradi, that is say near Nagpur, then Nashik, that is Eklare, Bhusawal, then the Paras, that is again near Bhusawal, we can say, then Parali, which is there in Bid district, then Khaparkheda, Chandrapur is nothing, the super thermal power station. And one can see on the extreme right side the installed capacities, and it will be definitely seen that the Chandrapur thermal power station is the largest producer of the energy that is obtained from the thermal power plants, 2340 megawatt. Okay, so that is the largest thermal power plant as far as the Maharashtra is concerned. So if we see one by one for the Koradi, so that is one unit of 200 megawatt and two units of 210 megawatt. So 210 into 10, that is 420, 420 plus 200, so that is 620 megawatt capacity. Likewise there for the Nasik, 630 megawatt. Bhusawal, the second largest we can say after the Chandrapur, okay, 1420 megawatt. Two units of 210 megawatt each and two units of 500 megawatt each. And the third largest is nothing but the Khaparkheda, 1340 megawatt, and largest is nothing but the Chandrapur super thermal power station, 2340 megawatt. So thus the total thermal capacity, or the total thermal capacity from the thermal plant rather, so that is very close to 8000 megawatt. So out of this 8000 megawatt, 2300, so slightly more than 25% itself is obtained only from the Chandrapur super thermal power station, isn't it? So largest share in Maharashtra is there for the thermal power stations. Uh, then next is nothing but the gas turbine power station. All these facts and numbers are for the year 2014. We'll also see what are the uh, current one and what are the projected one as well. Gas turbine power stations or gas turbine power plants, Uran gas turbine power plant, and the another one that is WHR 1 and 2. So the capacity very less, that is 672 megawatt, isn't it? So nearly it is one tenth as compared to that of the thermal power stations, the installed capacity of the thermal power station. So there is still an ambient scope, widespread scope, that the installed capacity can be improved, can be enhanced by the gas turbine power stations. Gas turbine power stations are the comparatively the compact as compared to that of the thermal power stations, and to a slight extent environmental friendly as compared to that of the thermal power stations, isn't it? So we'll discuss those points when we specifically target there onto the thermal gas turbine and hydro stations specifically. Then parameter C, the hydro power stations, the largest being the what you can say the Koina, 1956 megawatt, isn't it? So out of this 2585 megawatt, that is the total installed capacity that was for the hydro plants. So nearly 2600. So out of the 2600, nearly 2000 megawatt itself is obtained from the Koina. Isn't it? Stage 1, stage 2, stage 3, and stage 4. So 4 stages are in there. isn't it? So highest capacity, the highest requirements are being satisfied from the Koina hydroelectric power plant. Small hydroelectric power plants which may be located at different dams, smaller dams, isn't it? So like that of there is a Rajgarh, we are having the small, what do you say, the hydropower plants. Then the Ghatgar, that is 2 into 125. So 2 units, 2 turbines of 125 megawatt each. So 250 megawatt being the capacity. So thus the total generation capacity for the hydro plant that stands around 2585. So if we add these numbers A, B and C taken together, the capacity of the thermal power stations plus the capacity of the gas turbine power station plus the capacity of the hydropower stations. So these are only the conventional one. So that stands around 11,237 megawatt. Okay. So these numbers were from the 2014, and just after a small duration of 3 years, say 2017. Okay, these are the numbers for 2017. So it is there in the same sequence. Initially, the details for the thermal power stations. Then B is there for the gas turbine power stations, and lastly C, it is there for the hydropower station. And one point to be noted, as it is totally different from that of 2014 in nothing but the parameter D which is added here. Okay, in the 2014 we cannot see as such any D is there, isn't it? Thermal is there as A, gas turbine power station that is B, and hydro power station that is nothing but the C. So in this particular table for the 2017 installed capacity, the parameter D is added, non-conventional, that is nothing but the solar power plant, isn't it? So that way a slight addition has been say made in the non-renewable forms of the energy, renewable forms of the energy rather. That is nothing but the solar. As far as the Koran is concerned, so capacity is there 2,400 megawatt. So Koran it is only 5 to 7 that was been say mentioned here, isn't it? So that has been say increased to a large number. So it is seen that total thermal was nothing but a 7,980 megawatt. So now the total thermal have turned out to be 10,170 megawatt. Isn't it? From 8,000, nearly 8,000 megawatt has been improved to the 10,000 megawatt. It means that the 25% capacity addition have just taken place inside this 3 years as per at the state level is concerned. For the gas turbine power plant, here it was 672 in the 2017, 2014, sorry, 2014 it was 672. So as such, no change is observed there as far as the installed capacity for the gas turbine power stations are concerned. It is still 672. For the hydro, it is 2,580. It is 2,585. So not that much positive change can be seen there for the hydropower stations as well. So major capacity additions are there made in the thermal power plant stations or the installed capacity of the thermal stations. And smaller addition is there for the solar power plant. So thus the total capacity A plus B plus C plus D, thermal plus gas turbine plus hydro plus solar. So that turns out to be 13,602 megawatt. Okay. So it have increased from 11,200 to 13,600. So 2,500 megawatt capacity is added from 2014 to the 2017 to meet the increased requirements. Then these are the proposed plans or the future projects to satisfy the requirement that would be say there in the coming future. Okay, 5-year plan that has been taken into consideration from 2017 to 2022. Which shows the name of the project there to the extreme left column, then capacity, number of units, and the capacity, and the tentative commissioning year when that will be say put into practice. So this hour, that is unit number 6 is going to be added. Paras and Nasik unit number 6, Dondaicha power project, and the Uran gas thermal power station. Isn't it? So it is likely to be commissioned there in the 2019-20. So these are the plans for the immediate future. Okay, just 2 years down the line, then 2017 to 2022. Now, rather than say discussing these particular numbers, I will suggest all of you, just for the sake of your curiosity, you can visit the Mahagenco website at Maharashtra State Electricity Generation Company, and you can definitely find out some interesting facts and numbers, and you can make the appropriate comparison based upon your understanding. So I will not go into the details of this one. It has nothing but straight away the screenshot has been taken from that concerned site in the current work or the current capacity that is there. Okay, so such 2-3 different screenshots I have directly borrowed from the that is a generation Maharashtra State Electricity Generation Company Limited, Transmission Limited. It was taken from the Transmission Company Limited, State Electricity Transmission Company Limited. From the generation, from the distribution, you can also have the similar numbers. So I don't think it is very difficult or the uphill task to make these numbers available. Okay, so I will leave it these facts on your side and to make some research by visiting the concerned website. Okay. The ongoing projects or the current projects from the 2012 to the 2017. So that we are selling in 2012 to 2017, 5 years back rather, isn't it? So these capacity additions have been taking place. So that's why we have seen the addition of 2,500 megawatt from the 2014 to the 2017. Okay, in the two slides earlier that we have seen this number. So there was a capacity addition of 2,500 megawatt. So these were say some of the projects due to which the capacity has been increased. It is targeted that to add the 3,230 megawatt, but nearly 2,500 megawatt could have been achieved. That could have been increased. So not 100% of the target has been satisfied. Then these are the capacity additions. Just now we came across from 2017 to 2022. Name of the project, the corresponding capacity commissioning year, and some remarks are been there. That's what is the current state or the status rather, to the current position of that particular progress for the this concerned unit or the concerned project. Okay, I will suggest all of you to go through this table and you can make the comments in your own words. So that is there onto the first side of the unit number 1 there, first part of unit number 1, the discussion onto the energy scenario. Now we'll go on to the next topic for the discussion, which is nothing but the economics of the power generation. So I would like to appeal to all of you to keep your notebook open and write down some key points, which I will definitely ask you to write down in your notebook. So write down this title in your notebook: Economics of Power Generation. Because this part will be say dealing with not only some theoretical concepts and the methods, but numericals will also be involved for the calculation of the cost of energy. Okay, so numerical problems will also be involved. So I would appeal all of you to mention these points in your notebook. So open your notebook and write down the title there for the economics of the power generation. Now let us to first have the background for the economics of the power generation. That is why it is essential, why it is necessary that we should study or we should make an economic analysis for the power generation. Okay, so let us take these points one by one. The very first point that is mentioned here, the engineering thermodynamics emphasizes on maximum efficiency of the plant to be theoretically obtained. As far as the subject of the thermodynamics is concerned, so we are always interested that whatever the input that has been say, given to a particular system, so the maximum output can be obtained from that system. The energy entering the system must be equal to the energy leaving the system, isn't it? As far as the theoretical cycle is concerned, the different thermodynamic cycles are concerned. So we are always interested that the output should be as maximum as possible with the least amount of the input. So very roughly, very broadly, we give the definition of the efficiency is nothing but the output upon the input. And as this is nothing but say the power plant, so energy that is to be obtained from the power plant, and the input that is given, that is nothing but the fuel which is required to be supplied for the operation of that power plant. We always emphasize that we can get the maximum efficiency of the cycle or the maximum efficiency of the plant to be theoretically obtained. And obviously, theoretically obtained is nothing but the 100%. But we could never achieve the 100% theoretical efficiency. Number of losses would be involved there. Number of irreversibilities in completing the cycle will be involved. And we are not in a position to get the 100% efficiency. So this particular fact, that is to maximize the efficiency, okay, to maximize the efficiency. So it gives the strong bias, or it gives the strong reason for us. It gives the strong justification for all of us engineers that we should work in favor of the most efficient equipment. Isn't it? We should develop a boiler which will be having the highest efficiency. We should have a turbine which will give the maximum mechanical efficiency, thermal efficiency. We could have the alternator which can give the maximum electrical transmission efficiency. So all these equipment should be considered there for the maximized efficiency, because the efficiencies of these individual components will decide the efficiency of an entire plant. That is nothing but the overall efficiency of the plant, isn't it? Overall efficiency of the plant will be consisting of the efficiencies of all the auxiliaries which are used for the operation of the plant or the equipments. Compressor will be used. You need to work upon the efficiency of the compressor. You will be using the boiler. You need to work upon the turbine. Need to work upon the condenser. Need to work upon say the pumps for carrying out the say the water inside the system. You need to run the cooling tower, efficiency of the cooling tower you need to take into consideration. Then various what we say the energy recovery mechanisms which will improve the efficiencies, economizer, superheater that you studied in the thermodynamics, air preheater. So all these are nothing but the auxiliaries which are required for the operation of the that plant. So each equipment efficiency that should be taken into consideration, which will definitely have the direct impact on the efficiency of the entire plant taken together, isn't it? So that's why this efficiency gives the strong bias, strong reason for all of us to make this equipment most efficient one. And the power plant design must be made on the basis of most economical condition and not most efficient one, isn't it? Now this statement should be seen in some different manner, from some different perspective. Can we say that any equipment which is the most efficient one and it is the most economical one as well? So not this fact would be say true in all the cases, isn't it? The most efficient one may not be the most economical one. To get the efficiency to the very highest level, isn't it? Probably the more of the cost would be required in machining of that equipment to make that one more precise. So large amount of the cost would be involved in that one. So not all the time we can say that the most efficient equipment is nothing but the most economical one, isn't it? So both facts are what you can say the contradictory to each other, and there would always be appropriate balance between the two parameters. One that is nothing but the efficiency, and another is nothing but the cost of the operation or the cost of the production. So you have to make the appropriate balance between this, and then you can suggest the one suitable point. Yes, this is nothing but the acceptable efficiency which will give me the least cost of the operation or the least cost of for the energy generation. Otherwise, if you have the efficiency to be 95% and you are having the highest cost for that electricity, then possibly you won't find any consumer there who will purchase your electricity, isn't it? So you must maintain the proper balance for that one. Because the next point number 4 is very important again. Profit is the main basis in the design of the plant and its effectiveness is measured financially. Obviously, the companies which are involved there, either central, state, or the private sector companies. So they to generate the electricity and to sell that electricity, it is nothing but the business for these companies, isn't it? It is not just for the social cause there. They are generating, they are say investing some capital in that, and so definitely that particular entity, that particular party that will look into the appropriate return for the investment that they have made. So it is nothing but the business entity, isn't it? You generate that one and you sell it to somebody else, isn't it? So that's why profit is the main basis in the design of the plan, and effectiveness is measured financially. If you can get the handsome return for the investment that you have made in a particular plant, then and then only you will be interested in running that plant. Otherwise, if you are still say running your business there in the say the loss, then nobody is interested in running that business anymore, isn't it? If the losses incurred are more, so it is not uh, sustainable for that particular plant to run it for the longer duration, isn't it? So it is nothing but a kind of a business, and whenever you are dealing with the business, so profit is nothing but the main concern. The amount of the profit that may change according to the situation, according to the condition, but definitely profit would be there at the topmost priority for any business entity. So selling of power is nothing but the business only. The major purpose of designing the plant is to minimize the cost of energy produced, isn't it? So while you are designing any type of the power plant, you are generating the electricity, and when you are selling to the consumer, either the consumer may be the domestic, he may be commercial, or that may be the industrial consumer. So he will look upon the cost of the energy, isn't it? If you are offering at a higher cost as compared to your other competitors, so possibly you may not find yourself in some comfortable position, isn't it? So you should always try that you can keep the cost of energy generation at the lowest possible level, some rational level. So it will be acceptable by the any type of the consumer. And in majority of the cases, most thermally efficient plant is not the economical one. So that is what we were saying while discussing the point number two. Okay, it gives the strong bias or the reason to have the most efficient equipment. So most thermally efficient plant may not be always the economical one, isn't it? So you need to maintain again a proper balance, appropriate balance between the thermal efficiency of the plant and the cost of the electrical energy that you are likely to sell to the consumer, isn't it? So these are some of the points that we should take into consideration before the installation of the plant. That is what the background is there. Okay. Now let us look at the different types of the cost which are involved in the generation of an electricity. So I would like all of you to just write down these main points in your notebook. The two types of costs are normally taken into consideration in the cost of generation of an electricity or in the designing of the power plant. One that is called the fixed cost. First type of cost that is called the fixed cost, and other type of the cost is called the operating cost or running cost. Often it may be called as a variable cost in some of the books. Fixed cost, and second is operating cost, running cost, alternatively may be called as the variable cost, okay, which are likely to change with the duration. Then what are the costs which are taken to be consideration in the fixed cost heading? Yes, they are listed on the left hand side. Cost of land and building is a one time cost. You purchase the land and you construct a building, so that is one type cost. Equipments which are required to be purchased and installed, one time cost. Interest, depreciation, insurance, and cost of the management. All these are costs which fall under the category of the fixed cost. On the other side, The operating cost or running cost. The cost of the fuel. So that is nothing but the running cost. It is required there for the operation of the plant. So that is likely to vary on the daily basis. The cost of the oil, grease, cost of the water, and we can say the cost of the spare parts which may be say required in case of any maintenance. Cost of maintenance is also required, isn't it? So all those costs would be the operating cost, running cost, or the variable costs. So let us look at these different types of the costs one by one. Okay, initially we will discuss the fixed cost, and then toward the end of the session we will finishing with the types of the operating costs. Fixed cost, initially the fixed cost. So it is nothing but the capital which is invested in the installation of the complete plant. Okay, right from the purchase of the land till the entire plant has been say constructed and it is put into operation, isn't it? So it is nothing but the capital or the amount that is invested for the installation of the plant. And what it includes: cost of purchase of the land, cost of building, that is nothing but the cost of construction of that building, cost of the equipment. So possibly some of the equipments required to be imported from the other countries, isn't it? Some big turbines, big installations need to be say imported from the other countries. Cost of the transmission, the distribution lines, isn't it? So you need to install the transmission center, distribution centers. Okay, so transmit the energy from the location where it is generated to the location where it will be transmitted and then distributed till it reaches the end consumer. Cost of the planning, isn't it? So this is nothing but a logistic cost, I will say. Then designing the plant substations and many others. So these are nothing but the one-time costs which are incurred. So that's why they are called the fixed cost. It may further include the invested capital, insurance, maintenance cost, depreciation cost, that also we will discuss in the coming slides. So that the first cost is nothing but the cost which is involved in the installation of the complete plant, cost of land, building, transmission cost, planning cost, and the design of the substations. Land, building, and equipment cost. So it does not change much with the different types of the plants, but cost of equipment changes considerably. Yes. The cost of the land, so that may not say differ from one region to another region as far as the installation of the plant is concerned. Cost of the construction of the building, that will be more or less irrespective of the type of the plant. But the cost of the equipment definitely changes from one type of the power plant to another type of the power plant. Suppose for the thermal power plant, the equipment, suppose the boiler is there. Okay, you are burning either coal, oil, or gas inside the boiler. So cost of the boiler that you are taking into consideration for the thermal power plant. And now for the nuclear power plant, you don't have the boiler there in the nuclear power plant. It is a nuclear reactor rather. You don't have any combustion chamber. You are having the nuclear reactor. So cost of the nuclear reactor and cost of the boiler, so those would be definitely different. Isn't it? Cost of the construction of the nuclear reactor will be definitely higher as compared to the cost of the say the boiler for the thermal power plant of the same capacity, isn't it? Similarly, the cost of the gas turbine plant or gas turbine, cost of the compressor, that will be different. Cost of the hydraulic turbine, the Francis Kaplan turbine, even though the capacities would be same, installed capacities would be same for thermal, for nuclear, for hydro, for gas turbine power plant, but the cost of the equipment is likely to be different. It will never be same. But the cost of the land and building, so that will be more or less the same irrespective of the type of the plant, isn't it? So that's why it has been stated here that the cost of land and building does not change much with different types of the plant, but the cost of the equipment definitely changes considerably, isn't it? The cost of the equipment is usually expressed on the basis of kilowatt of installed capacity. The unit which is there for the equipment is normally considered as how much cost in rupees per kilowatt of the installed capacity is there. So these many rupees per installed capacity. The capital cost per kilowatt of the installed capacity does not change much for the thermal plant. Okay, it means that a thermal power plant to be installed at this location and thermal power plant that's likely to be installed at some 500 kilometers away. So that capital cost may not be say that much of the difference. It may not change, but definitely changes as compared to if the hydro plant is taken into consideration, because we need to look at the availability of the water across the river when we are say constructing that hydropower plant, isn't it? Then the head that would be available for the dam, which will say store the water, that we need to take into consideration. Whether this site is suitable for the installation of the hydro plant or not, that need to be taken into consideration. Whether the people we are those are say living in that area, they need to be shifted somewhere else. Then some social problems, agitations are likely to come into picture for the installation of the hydropower plants, isn't it? So all these parameters will be say playing a major role in the hydropower plant, isn't it? So the cost of the hydropower plant will be definitely changing from location to location. Quantity of the water, then the head which is available there, then the social impact that will be say made due to the construction of the hydropower plant. So all these factors need to be taken into consideration. So that is what it is stated in the last line rather. The cost of the hydro plant depends upon the foundation available, the type of the dam, the spillways which are used, available head and quantity of the water. Isn't it? So depending upon the head available, the different turbines that you have studied in the turbo machines. High head, that is nothing but the Pelton wheel, medium head, that is the Francis turbine, and low head, it is nothing but the Kaplan turbine. Depending upon the quantity, that is the discharge available. If the discharge is less, then you will go with the higher head, that is nothing but the Pelton wheel. Discharge is say medium with the medium head, the Francis turbine. And if the discharge is high but the head is low, then you will go with the third type, that is nothing but the Kaplan turbine, isn't it? So these types of the heads and discharges will affect the selection of the equipment for the hydropower plant. So hence it is stated in the point number 3, the capital cost per kilowatt of installed capacity changes a lot in the case of the hydropower plant. Okay, so that is the justification for that point number 3. The another say parameter which makes the contribution for the fixed cost is nothing but the interest. So what is nothing but that interest? Whoever being the say the investor in that plant will be definitely looking for some handful returns. He will be looking after the profit, how much profit that he can get from this investment, from the capital he is likely to invest in the installation and operation of that plant. So interest on the capital invested must be taken into consideration, because now if the same amount would have been or same capital would have been invested somewhere else in other profitable business, in the share market, in some mutual funds, or in some bank deposits, if the same amount would have been made, so how much return that I would get from that one? Some X percentage would be the rate of the interest which would be obtained if the same amount is invested in some other instruments, and the amount that is invested in the installation of the plant, then how much return that I will get. So I should make the calculations for that interest as well. Then and then only that particular power plant would be considered to be the profitable one. Otherwise, the any financer or any investor won't be still looking into this huge investment. He will be always looking upon some interest. He will be always looking upon about some return he can get from that investment. So hence a suitable rate of interest must be considered, must be taken into consideration on the capital which is invested by the investor or financer, we can say, isn't it? The another type of the cost which is involved there in the fixed cost is nothing but the depreciation. So what is the depreciation? So let us look this point by point. It is the amount to get aside per year from the income of the plant to meet the depreciation caused due to wear and tear of the equipment. It means that you are installing a new equipment right now. It will say giving you some performance at the present condition. But over a period of time, we know that its performance is going to be deteriorated due to the wear and tear of the different parts. Maybe some reciprocating, maybe some rotating part there, isn't it? So due to various reasons, its performance is likely to get reduced, likely to get decreased. So it means that the value of that equipment is going to reduce over a period of time. Okay, so reduction in the cost is nothing but the depreciation, isn't it? Suppose I purchase a vehicle today for some 50,000 rupees, and if I want to sell it after a year, I won't get the same price of 50,000 rupees. I have to sell it at some lower prices. So let us say I'm selling it at 40,000 rupees. So there is a depreciation of 10,000 that have occurred. So reduction in the value of that asset, decrease in the value of that equipment is nothing but the depreciation. So why this cost should be taken into consideration? Because the performance of the equipment that reduces over a period of time. It doesn't give a consistent performance for years together. Why? Because the wear and tear is nothing but the inseparable part of the operation of any mechanical equipment. So that's why the depreciation must be taken into consideration. So invested capital of the plant installation must be recovered by the time lifespan of the plant is over. So it can be replaced by the new plant. It means that whatever the cost which has been kept aside every year under the category of the depreciation, so that amount should be in such a way that by the time the lifespan of that instrument is over or that equipment is over, so the amount that I have kept aside, so that will be helpful for me to replace the old plant with the new plant, isn't it? I should have that money with me. So I should keep aside every year this much amount every year, and so that after completion of the lifespan of that plant, I can replace it by the newer one, isn't it? So that is always desirable. Such amount is accumulated till the plant is in operation. I expect the life of the plant to be 30 years. Okay, the plant has been say, put into operation today, new plant, and I expect that the plant is going to last there for the 30 years. Life of the plant is 30 years. So every year I should keep some amount aside from this year till the end of the 30th year. And when I realize that at the end of the 30th year, I need to replace this plant. So whatever the amount that I have accumulated over the period of 30 years, I can utilize that amount, and that will be helpful for me to replace it by the newer equipments, newer plant, so that I can continue with the business. So that is the idea there. For the cost of the depreciation must be taken into consideration. The amount collected by the depreciation by the time plant retires or the life of the plant gets over complete is equal to the capital invested in the installation of the plant. Yes, it has to be there. Then and then only it will be possible for me to replace by the new one. The different methods are there for the calculation of the depreciation. These are the three commonly used methods: straight line method, sinking fund method, and third one is nothing but the diminishing value method. So these three methods will be used to calculate the depreciation, and we'll see what different formulas, equations are there for calculation of the amount of the depreciation when we'll solve some of the numericals for the economics of the power generation. So for the time being, just note down these three methods for the calculation of the depreciation amount: straight line method, sinking fund method, and diminishing value method. Another parameter which makes the contribution there for the fixed cost is nothing but an insurance. So insurance becomes necessary to insure the costly equipments for the risks such as the fire or any accident, any undesirable thing that is likely to happen in the future, isn't it? So due to say the storm, some things are being devastated, due to say the floods, your machineries are getting badly affected. So to face such risks, so it is always essential that the costly equipment must be insured. So if in case of any damage, so they can be replaced with the help of the insurance that you are, or the premium that you are paying for the insurance company. So fixed sum is set aside every year as the insurance charges. Now you know that the insurance for your vehicle, isn't it? So you definitely give some premium to the insurance company, and if any damage, if any accident occurs and your vehicle gets damaged, so you can claim this particular damage to the company, and you can get it replaced by the newer one. So you need not to pay from pockets. So some amount must be kept aside to that one. The annual premium may be 2 to 3% of the entire cost of the annual installation, but this may be quite high, quite heavy, or quite high, as the capital cost of the plant is very high. Even though it looks to be the 2 to 3% looks to be a very small thing, but the cost of the installation of that plant may be in hundreds and thousands of crore, isn't it? So 2 to 3% of the 1,000 crore, you just imagine that how much amount just had to be kept aside only for the insurance premium. So definitely the costly equipment must be given, say the security with the help of the insurance, isn't it? So it acts as a shield there. So you need not to pay from your pockets. The management cost, which is also nothing but the fixed cost, it includes the salary of the people which are working in the plant, salary, the wages, or the incentives that you are likely to give to your working personnel, isn't it? So that is nothing but the fixed cost. Even though that your plant is working or not, due to some or other reason, still the salaries has to be paid for those people which are working in the plant. So therefore, it is included there in the fixed cost of the plant. Okay, so the management cost. So all the costs that we discussed earlier were falling under the category of the fixed cost. So this will be the one-time cost always. Operating cost, the cost which are used for the operation for running of that plant successfully, or the variable cost we can say, the cost of the fuel, the cost of the oil, the cost of the what you can say the coal, the cost of the gas. So those are not going to remain constant all the time. It's not a one-time cost. Huh? You have to purchase the coal, you have to purchase the fuel time and again. So today's cost of the fuel may not be the same after 1 month, after 2 months. So that is going to change. So hence it is nothing but the variable cost. So it is proportional to the amount of energy generated. So definitely you need to produce a larger amount of the energy. So definitely larger amount of the input, larger amount of the fuel must be supplied. So that is directly proportional to each other. If you want the larger output, then the similar larger input must also be given. The rate of fuel consumption per unit of energy generated also varies according to the load on the plant. Isn't it? It is very important observation. The rate of fuel consumption per unit of energy generated also varies according to the load on the plant. Now we know that any plant is supposed to be designed, suppose for 100 megawatt this plant is supposed to be designed. And you operate that plant to the 50% capacity only, 50 megawatt. It is working under the partial load condition, isn't it? Actually, the plant is designed for 100 megawatt and you are running it for the 50 megawatt. It means that you are not utilizing the fullest capacity of the plant. Now, whatever the invested that you have made for the 100 megawatt, you are not utilizing it to the fullest extent, isn't it? So it is not desirable that your plant should work under the part load condition. You should always make an effort that your plant would be operating to its fullest installed capacity, isn't it? So that is mentioned in the point number 3. The consumption of the fuel per unit of energy generated is minimum at full load of the plant because the prime mover works at the maximum efficiency at the full load conditions. Isn't it? Obviously, plant is designed for the full load condition. You should always run it for the full load condition and avoid the operation of the plant at the part load conditions. So which will adversely affect the cost of the fuel, cost of the operation. Then these are some what you can say the miscellaneous cost of the oil, grease, water which is required for cooling, and heating of say various equipments. For generation of the steam, for condensation of the steam, you need the water. For cooling of the various utilities for the operation of the plant. Then to reduce the what you can say the uh, uh, losses due to friction, you need to make use of the oils, isn't it? So all these costs are also proportional to the amount of electricity generated. You generate the larger amount of electricity, you need the larger amount of the oil, grease, and water. All these are nothing but the consumables. These are the consumable costs. So this cost increases with the increase in the lifespan of the power plant as the efficiency of the power plant decreases with the age, isn't it? So your equipments will not give the same performance after 30 years as of now it is today, isn't it? So the cost of the maintenance would be higher. It means that the cost of oil, grease, or the regular maintenance that will be higher. So that's why the cost increases with the lifespan of the plant. And toward the end, I will say that the total cost of the energy produced is then the sum or the addition of the two costs. One that is the fixed cost or the fixed charges rather. I have forgot here G there. Fixed charges and the operating charges or the variable costs. So the common way to represent the cost of the power, capital C. So it is a two component. First, X rupees per kilowatt of the installed capacity. So that is nothing but the fixed cost. Just now we have seen the fixed cost is nothing but the cost of installation per kilowatt of that equipment. So X rupees per kilowatt of the installed capacity plus Y rupees per kilowatt hour of the energy generated. That is variable cost. So the first point here, okay, first part of this equation is nothing but the fixed cost. This is nothing but the fixed cost. And the second part is nothing but the variable cost or the operating cost. This is a very general way by which the cost of the generation can be given. So total cost C equal to the fixed cost of the plant plus the operating or running cost of the plant. Is that fine? So we are almost now near to the end of this particular lecture. We'll stop here for the today's discussion, and I hope that you might have definitely recorded these points which were falling under the category of the fixed cost and the variable cost. And maybe in the coming session, we'll be say solving some of the problems uh, for the determination of the cost of the electrical energy. If not, then what are the different methods for calculation of the energy that we'll discuss. Okay. So that's all from my side for the today's session. So thank you for your patience listening, and we'll come back in the next week with some the topics of interest for our subject. So thank you very much. Okay, stay home, stay safe. Thanks once again.